Hello everyone, welcome to Easy Maths Tutorials. In this tutorial, we are going to learn about the fundamentals of sequences and series. What are the applications of sequences and series in the day-to-day life? So sequences are useful in a number of mathematical disciplines for studying functions, spaces and other mathematical structures. Using the convergence properties of sequences, in particular, sequences are the basis for series, which are important in differential equations and analysis. Sequences are also of interest in their own right and can be studied as patterns or puzzles, such as in the study of prime numbers. So in our previous tutorial, we learned about the arithmetic progressions where we found the formula for the n term and also the formula for the sum of the first n terms. In this tutorial, we are going to learn about geometric progressions. We are going to find out the formula for the nth term and the formula for the sum of the first n terms of a geometric progression. A geometric progression is a sequence of numbers such that the ratio of any term to the preceding term is fixed number called the common ratio, and it is denoted by r. For example, 2, 4, 8, 16, where the common ratio r equals to 2. In the sequence 5, 15, 45, 135, the common ratio r equals to 3. Formula for the nth term. Consider a general geometric progression a1, a2, a3, where n-1th term is an-1 and the nth term is an, and so on, with common ratio r. Then an over an-1 equals to the common ratio r for all n equals to 2, 3, 4 up to infinity. Then a2 equals a1 times r, a3 equals a2 times r, and by substituting for a2 we get a1r times r, which equals to a1 times r squared. Then the fourth term a4 equals to a3 times r, which equals to a1 r squared times r, which equals to a1 times r cubed. Therefore we see that an equals to a1 times r to the power n take away 1. Then the nth term of a geometric progression is given by the formula an equals a1 times r to the power n take away 1, where a1 is the first term and r is the common ratio. Example 1. Find the seventh term of the geometric progression 1, 1/3, 1 over 3 squared, and so on. So the common ratio is 1/3 and the first term is 1. Therefore by substituting in the general equation for the nth term, 1 times 1/3 whole thing to the power 6, which equals to 1 over 729. Example 2. Find the first two terms of the geometric progression in which the common ratio is 3 and the sixth term is 162. According to the information given in the question, common ratio is 3 and the sixth term is 162. Therefore by substituting in the general equation for the sixth term, we get a6 equals to a1 times r to the power 5. Then making a1 the subject of the formula, we get a1 equals 162 over 3 to the power 5, which equals to 162 over 243. That is a1 equals to 2/3. If the first term is 2/3, by multiplying the common ratio we get the second term, therefore a2 equals to 2. Formula for the sum of the first n terms. Consider the sum of the first n terms a1, a2, a3 up to an take away 1 an of a geometric progression. Then Sn equals to a1 plus a1r up to an r to the power n take away 1, which is the first equation. Then by multiplying both the sides by r, we get rsn equals a1r plus a1r square to an r to the power n. That is considered as the second equation. Now subtracting equation 2 from equation 1 gives 1 take away r times Sn equals to a1 take away a1 times r to the power n. Therefore by making Sn as the subject of the formula, we get Sn equals to a1 times 1 take away r to the power n over 1 take away r, where r is not equal to 1. Example 1. Amal starts working for an annual salary of 150,000 rupees. He is promised a 10% increment each year. What will be the salary in the fifth year? What would be his total earnings during the first 5 years? According to the information given in the question, the fifth term of the geometric progression has to be found. So A5 equals to A1 times r to the power 4, which equals to 150,000 times 110 over 100 whole thing to the power of 4, which equals to 150,000 times 11 over 10 whole thing to the power of 4, which is 219,615. That is, Amal's annual salary in the 5th year is 219,615 rupees. In order to find the total earnings during the first 5 years, we use the formula for the sum of the first n terms of the geometric progression, which is Sn equals to A1 times 1 take away r to the power n over 1 take away r. Substituting the values, S5 equals to 150,000 times 1 take away 110 over 100 whole thing to the power of 5 over 1 take away 110 over 100, which equals to 15 times 100,000 take away 161,051 over negative 1, which equals to 915,765. That is, Amal's total earnings during the first 5 years is 915,765. Now try out this question by yourself. Dylan decides to save money by making monthly deposits starting with an initial deposit of 100 rupees and then each month doubling the amount she deposited a month. How much would she have saved at the end of 6 months? So the solution can be gained by substituting the values in the sum of the first n terms of a geometric progression. Here the common ratio is as the amount she deposits each month is doubled. So S6 equals to 100 times 1 take away 2 to the power 6 over 1 take away 2, which equals to 100 times 1 take away 64 over negative 1, which equals to 6,300. Therefore, the amount that she would have saved at the end of 6 months equals to 6,300 rupees. So that's it for this tutorial. I hope you enjoyed learning about geometric progressions. If you like this tutorial, press the like button, and if you have anything to say about the tutorials, you can type in the comments below. Also, subscribe to Easy Maths Tutorials channel to get instant access to the tutorials. Thank you.